What's up guys, and welcome to this video tutorial. We are going over the 2019 IEB exam. We've done some questions. I want to skip through some of these questions and I want to move straight to question 7. Okay, so question 7 is basically an implicit differentiation question. And you'll see these kinds of questions coming up quite often. So it's a nice free 10 marks if you know how to do it. So yeah. So let's go through this question. So below is the graph of the relationship y cubed minus xy is equal to y plus x squared. It's a nice graph, and it says determine the equation of the tangent, so what's shown in the dotted line, if it is known that the x-coordinate of the point of contact is 1. Okay, so we know what the x-coordinate of the point of contact is. Where am I going to do this question? Okay, let me start it here. So let's do question 7. So basically what we need to start off with is, what is our equation? So our equation is y cubed minus xy is equal to y plus x squared. Okay, so we know that the x-coordinate, so let x is equal to 1. So if x equals 1, we have y cubed minus y equals is equal to y plus 1. Okay, so that's y cubed minus 2y minus 1 is equal to 0. Okay, now I'm going to just plug this into my calculator. So that's, if you're using the Casio, it is mode 5, and then I'm going to go for option 4. I'm going to plug in 1 for A, 0 for B, minus 2 for C, and minus 1 for D. And I get answers of y is equal to okay, so there's 3 answers here, so let's go through each one. Y is equal to 1,618, or y is equal to minus 0,618, or y is equal to minus 1. Okay, so we have to go through each of these and figure out which one it actually is. Okay, so obviously y is below the x-axis. Okay, so it can't be that option. So we're left with minus 0.618 and minus 1. Okay, so if this is the point positive 1, then you could say that this is roughly equal the same distance here, assuming these scales are correct. So y is equal to minus 1, so it can't be this option either. So basically what we get is that we get y is equal to minus 1. Okay, so using that information, let's call this point A. So our point A is equal to 1 and minus 1. Okay, those are the coordinates. Okay, now we need to take this equation and do some implicit differentiation. Okay, and the implicit differentiation is basically used to get our gradient for our equation. Okay, so how do we do implicit differentiation? Where we see y, it is not, we don't treat it as a constant, but we differentiate it in terms of dy dx using our normal differentiation rules. So using the chain rule, this is going to be equal to, let's not switch colors. So using the chain rule, this is going to be equal to 3y squared, and then dy dx minus, okay, we're going to use the product rule here. I'm actually going to put brackets around it. So using the product rule, we differentiate the first, so differentiating x, that's just 1, and then we're left with y, plus we leave the first now, and we differentiate the second, which is just dy over dx, is equal to the derivative of y in terms of x is dy over dx, plus differentiate x squared is going to be 2x. Okay, so now that we have that nicely, let's multiply this minus out. So we have 3y squared dy dx. We're going to bring this term across as well, so that's minus dy over dx minus y minus x dy dx is equal to 2x. Okay, so I'm going to group the dy dx terms, so dy over dx is equal to 3 multiplied by 3y squared, got rid of that term, minus x, got rid of that term, minus 1, got rid of that term, is equal to 2x plus y. Okay, so dy dx, or my gradient, is equal to 2x plus y all over 3y squared minus x minus 1. Okay, so that basically gives me my gradient, or the equation for my gradient, equation for m is equal to that. So now I substitute my values for the point A. So dy dx, basically x is going to be equal to 1 and y is going to be equal to minus 1. So what we have is 2 times 1 minus 1 all over 3 times minus 1 squared minus 1 minus 1, which is equal to 1 over, so that's 3 minus, okay, so it's just equal to 1. So it's 3 minus 2, which is 1, which is equal to 1. So that's very nice. Our gradient comes out as being 1. Okay, so now we know what our gradient for our tangent is. M is equal to 1. And now we just use our normal formula for a straight line graph. So that is y minus y at point A is equal to m, my gradient, x minus x coordinate at A. So y, and my y coordinate was minus 1, is equal to 1 times x minus my x coordinate, which was 1. We're substituting those values in. So what you get is y plus 1 is equal to x minus 1, so y is equal to x minus 2. And that is the final solution. So nothing too difficult, a little bit of implicit differentiation. In some questions I've seen them hinting at implicit differentiation. In this question they did not, so you just have to know. Then in order to get the tangent, we first use implicit differentiation. Okay, no, that's a lie. The first thing we needed to do is get coordinates. Okay, second thing we got was implicit differentiation, and from that we get m, or our gradient. And then the third thing we do is we know a point on the graph, which is at point A, so we use the equation for a straight line graph and a point and some point. Okay, so nothing too difficult there, and we get a nice 10 marks. So yeah, thanks for watching, guys. I hope you found this tutorial useful.